So you've got your computer science minor project. It feels like a huge milestone, right? But what if we looked at it a little differently? Instead of seeing it as just another requirement to check off, think of this as your first real chance to be a builder, a scientist, or even a detective, someone who solves a genuine, real-world problem.
And look, if you're feeling a bit overwhelmed by it all, that is totally 100% normal. You're suddenly expected to manage a team, do your own research, and deliver a pretty significant piece of work. The pressure is absolutely real. But what if the goal wasn't just about getting a grade, but about making a tangible impact?
Okay, so this quote right here, this is basically the official mission statement for the project. And notice the key words, apply it to real-life situations. This isn't about some abstract theory. It is a direct command to go find a real-world problem and use your skills to tackle it. And that right there is where things get really exciting.
So, how do you find the right problem to solve? Well, I think it starts with knowing what kind of problem solver you are. To make it easier, we've broken it down into 3 main paths. Think of them like archetypes. The question is, which one sounds most like you?
So which one are you? Are you the builder? The person who just loves to create something that works, something tangible you can show people? Or maybe you're the scientist, driven by that need to test, to measure, to really understand how systems perform under pressure. Or are you the detective, the one who loves digging through mountains of data, hunting for those hidden clues? Let's actually dig into what each of these paths looks like in the real world.
All right, first up, the builder. This path is all about taking a visible, everyday problem and constructing a real solution for it. You see something that's broken in the world and you just get this urge to build the tool that will fix it. And what's a perfect problem for a builder? Well, take a look at this. Anyone who's spent any time in Bhubaneswar knows the traffic is, let's just say it's getting a little crazy. It's a daily headache for thousands of people, but for a computer science student, it's a golden opportunity.
I mean, the scale of this problem is just mind-boggling. Check out this number. The city's roads were built to handle about 8 lakh vehicles. Today, we're talking nearly 20 lakh. The system is just completely overloaded, and when you throw illegal parking into the mix, oh man, it just makes everything 10 times worse.
But here's the really interesting part. This is the hidden insight. The city did the logical thing, right? They built these high-tech, multi-level car parks to solve the problem. But they're empty. Why? It all comes down to human behavior. Drivers figured it was just easier and cheaper to park illegally than to deal with the fees. So the purely tech-focused solution, it failed because it didn't solve the people problem.
And this is where a builder's project can really shine. You see, this isn't just another find a parking spot app. No, this thing is designed to solve that behavioral problem we just talked about. You've got real-time views so you know where spots are, easy in-app payments, dynamic pricing to make legal parking more attractive, and even a feature to empower people to report illegal parking. Now that is a smart solution.
Okay, so that's the builder. Now let's switch gears and talk about Path B, the scientist. If the builder is all about creating solutions for the outside world, the scientist loves to go deep, to run experiments to understand the inner world of our computer systems. This is for all of you who just love to ask why and how. And here's a huge, fundamental problem they might tackle: blockchain's energy crisis. You know, the original blockchain algorithm, proof of work, is super secure, but man, it uses a shocking amount of energy. It's basically this global race where tons of computers are trying to solve these super complex puzzles just to validate a transaction. It works, but the electricity bill is astronomical. This is a massive problem for the industry and for the planet.
So the industry comes up with a potential solution, a different algorithm called proof of stake. But here's the catch. It's not a simple swap. It's a fundamental trade-off. You've got proof of work on one hand. It's slower, it's an energy hog, but it is battle-tested and super decentralized. Then you have proof of stake. It's way faster, way greener, but it brings up totally different security questions. So how do you even begin to decide which one is better?
Well, you run an experiment. That's what a scientist does. A scientist project culminates in something that looks a lot like this table. You'd build simplified versions of both algorithms, and then you just measure everything. Transaction speed, how much computation it takes, how long to add 100 blocks. This table, this isn't just a bunch of numbers. This is evidence. You are providing cold, hard data to help answer one of the biggest questions in the field today.
All right, last but certainly not least, let's talk about our third path, the detective. For the detective, It's all about the data. They're the ones who can take these messy, complicated data sets and hunt for the hidden patterns, the insights that can tell us about the future or explain the past.
And here is such a powerful real-world problem for a detective to sink their teeth into. The state of Odisha is, and this is amazing, world famous for its zero-casualty cyclone evacuations. They save millions of lives. It's incredible. But after the storm is over, after people go back home, a second, slower disaster unfolds, the complete collapse of the power grid.
And the scale of this failure is it's hard to wrap your head around. After Cyclone Fani hit, we're talking 3.5 million households without power. That's not just lights out. That's hospitals on backup generators. That's water pumps failing. That's communication networks going dark.
So a detective arrives at the scene, right? And what's the first thing they do? They gather the evidence. They look at the specific damage reports. 156,000 utility poles destroyed. 4 major grids gone. Thousands of kilometers of power lines just torn down. This is the raw data.
And this is where the real detective work begins. The goal here is predictive analysis. You'd use tools, probably Python with pandas and matplotlib, to literally overlay the tracks of past cyclones onto a map of the power grid. By connecting the dots between storm intensity and the specific damage that occurred, you can build what are called fragility curves, basically a model that can predict future damage. You can finally answer the critical question. Okay, if a storm like that one hits just 50 kilometers to the north, where are we going to break?
So, whether you chose to be a builder, a scientist, or a detective, your work isn't done just because your code compiles or your analysis is finished. There's one last crucial step, showcasing your solution. And honestly, this is the part that can turn a simple college project into a serious asset for your career.
And I really want this point to land for every student out there. Your final report, that PDF, that's for your professor. But your GitHub repository, that's for the world. That's for every future employer who wants to see what you can actually do. It's your living portfolio.
So you have to treat it like a professional product. That means a crystal clear README file that tells people what your project is and exactly how to run it. It means including everything. The source code, the report PDF, your presentation slides. Use discoverable tags so other people can find your work. And of course, please write clean, well-commented code. This level of professionalism is what will make you stand out.
So, as you get started on this whole journey, just remember this. You have the skills to be a builder, a scientist, or a detective. This project is so much more than just another assignment to check off a list. It's a genuine opportunity to find a real problem, something you actually care about, and make your mark. So the only question left is, what problem are you going to solve?